So here we have a problem that says if x plus 3y to the power of 1/3 is equal to y, what is dy dx at the point 2, 8? So what we're trying to find is dy dx at the point 2, 8. So we need to find the dy dx means the derivative. So we need to first find the derivative and then plug in 2 for x and 8 for y. Because this equation x plus 3y to the power of 1/3 is equal to y, this equation is not simple to solve for y and take the derivative with y by itself. We need to use the process of implicit differentiation. So using the process of implicit differentiation, we will take the derivative, but each time we take the derivative, using the idea that y is a function of x, we will multiply by dy dx as like a variation of the chain rule. Okay, so the derivative of x is equal to 1. That term is by itself, so we'll just bring it down. 1 plus the derivative of 3y to the 1/3, we'll use the power rule on the y to the 1/3. So just bringing down the coefficient 3, and then using the power rule, which is the derivative of a variable to the power of a number is equal to, you bring the number down, you subtract the exponent by 1. So we'll bring down the 1/3, so this will be 3 times 1/3. Y to the power of 1/3 minus 1 is negative 2/3. But then because we took a derivative of a y, we need to multiply that by dy dx. So that's our implicit differentiation rule. And then is equal to, the derivative of y is 1, but then again, because we're taking the derivative of y, we need to multiply by our dy dx. Okay, so here's our first step of taking our implicit differentiation derivative. The next thing we need to do is to simplify. So we have a 3 times 1/3. The 3 and the 1/3, the denominator 3 will cancel out. So that leaves us with 1 plus y to the negative 2/3 dy dx is equal to 1 times dy dx is just dy dx. Okay, our next step is we want to isolate all of our terms with dy dx on one side. So I'm going to subtract this term to the other side. So minus y to the negative 2/3 dy dx on both sides. So from here, that makes 1 is equal to dy dx minus y to the negative 2/3 dy dx. Okay, so now I have all of my terms with my dy dx on one side. From here, I'll factor out my dy dx. So that makes 1 is equal to dy dx times 1 minus y to the negative 2/3. And now I can divide both sides by what my dy dx is multiplied by. So that would be dividing both sides by 1 minus y to the negative 2/3. So this cancels out and leaves me with dy dx by itself, and then 1 over 1 minus y to the negative 2/3. Okay, so now I've found my derivative because I've solved for my dy dx, but my problem wants me to find my derivative at the point 2, 8. So for all our values of x, or for all our x's, we plug in 2. For all of our y's, we'll plug in 8. We are only left with a y, So we'll plug in 8 here. That makes 1 over 1 minus 8 to the power of negative 2/3 is equal to dy dx. Okay, so now we need to simplify. We can first make this negative exponent a positive by making it a fraction. So that would be 1 over 1 minus, that would be 1 over 8 to the power of positive 2/3 is dy dx. And I really should say that this is evaluated at 2, 8, because this is evaluated at a particular point. Okay, from here we can use the rule that a fractional exponent can be turned into a radical by using the formula. If we have x to the power of a over b, that is the b root of x to the power of a. So this means 1 over 1 minus 1 over the cube root of 8 to the power of 2. All right, so simplifying that, I'll just simplify going this direction, is the cube root of 8 is 2, so we can also square it after we take the cube root. So the cube root of 8 is 2, 2 squared is 4, so that would be 1 over 1 minus 1 over 4. Making a common denominator, we can do 1 over 4 minus 1 over 4 is 3 over 4 when we subtract. So that would be 1 over 3 over 4, which then we flip the denominator and we make that into 1 times 4/3, which is 4/3. So the final answer would come to 4/3 in this problem. Okay, well, I hope that that was helpful. If you have any questions, feel free to leave those in the comments, and subscribe to my channel to get more notifications of homework help problems like this. And let me know if you would like to see any live streams. I'm going to work on getting some live streams coming up in the future. Alrighty, well, happy studies.